Hi, I'm Michael.
Hi, I'm Anthony.
And this is the Spot of Arago.
Yeah.
So the Spot of Arago is a result of the Huygens-Fresnel principle, which states that at every point in the plane of the obstacle is a point source of light. So if we have a circular aperture, we'll basically have infinitely many point sources along the circumference of the aperture. From each of these point sources, we'll have a wavelet of light being emitted. These wavelets have an optical path difference of 0. So at the center of the shadow, they'll constructively interfere since they're in phase. Since they're constructively interfering, we should see a bright spot at the center of the shadow, which is the spot of Arago.
As mentioned previously, in the 1800s, Fresnel's wave theory was met with great controversy because light was, at the time, accepted as particles. One critic of this theory was Simeon Poisson, who used Fresnel's equations to calculate that there would be a bright spot in the center of the shadow of a circular aperture, which he concluded would disprove the wave theory. A few years later, Francois Arago actually performed this experiment and found that there was indeed a bright spot at the center of a circular aperture shadow.
So here's our experimental setup. We have a Heine laser, which goes through a diverging lens, and then we have a beam chopper, which will modulate the signal. Over here we have our circular aperture. In this case, it's a coin that's suspended by a metal wire. And over here we have a photodetector where we can measure the intensity of the spot of Arago.
Here we have our circular aperture, and we can see the spot of Arago.
Here we have our spot of Arago measurements. So we used a modulated signal frequency of 350 hertz, and we found that our peak-to-peak voltage around the spot, our dark reading, was about 4 millivolts. This in contrast with the peak-to-peak voltage at the spot, which was 10 millivolts, and the peak-to-peak voltage without the aperture at all was 40 millivolts. These two values here clearly show that the spot intensity and the intensity of the unaltered light are proportional. However, we don't think that this actually reflects the true values of intensities of the light.
This is because the detector does not do a good job at collecting all of the light from the spot of Arago. This means that the signal generated by the spot is going to be lower than what it should have been. If we're to use a detector that does a good job at collecting all of the light from the spot, we should get a signal that is of same intensity as if there were no aperture.
Error in this intensity measurement can also be attributed to the fact that it is very difficult to get our circular aperture completely perpendicular with the incident light. This means that the light diffracting around the circumference of the aperture will have different optical path differences and thus won't constructively interfere in the center of the shadow, canceling out the spot of Arago.
One big factor in determining whether or not a circular aperture will produce a spot of Arago deals with the surface roughness along the edge of the aperture. So if the aperture has a very smooth surface along its edge, then it will produce a spot of Arago. This can be seen with our nickel, which has a very smooth edge, thus will allow it to create a spot of Arago. However, if we just switch out this nickel with a different aperture, let's say this knob, which clearly has a lot of tiny divots around its edge, these divots make the surface roughness very large for this aperture, so we should not see a spot of Arago formed. So right here we have our equation that must be satisfied by the aperture in order for there to be a spot of Arago formed. Right here our variables are delta r is the surface roughness of the aperture, our r is the radius, lambda is wavelength, g is the distance from the source of the laser to the obstacle, and b is the distance from the aperture to the viewing plane. If we're to plug these values in, which were measured for the knob aperture, we find that the surface roughness of the aperture must be less than 21 microns. However, with a caliper, we measured that the surface roughness of the knob aperture is 500 microns, therefore the knob should have no spot of Arago.
Here we can clearly see that there is no spot of Arago present.